task was to design a 1,000-meter tall mega tower in the Middle East, in Qatar, and we basically had to do a sort of half-in-depth preliminary study consisting of reviewing the foundations, the primary structure, wind loads, all sorts of aspects that you would look into. It's sort of the first review stage of the process in actually building any building.
As the building had a tapered cross-section, it meant each individual floor would be different. So therefore, we had to design many different types of beams, columns and connections.
To create something that's not been done in real life is a massive challenge. The tapering cross-section was very tricky to design for, especially because the core couldn't taper. It had to step in as the height went up the tower. So to fit this in with the shape of the tower and the other elements was very tricky.
The models are mounted on base plates, and in an actual wind tunnel you would mount them upside down, and then the wind tunnel has capabilities of running up to 40 meters per second wind speed, and we're doing some basic tests in terms to see wind-induced moments on the base are, so we could account for that in our foundation design. And we were also looking to do some shape optimizations in terms of wind flows around the building, so we could pick the most optimal shape and then minimize the number of structural elements in the design.
The results showed that the triangular model had reduced moments in terms of a long and a cross wind. This was when compared to the geometry of the square tower. This is why throughout the project we've been developing all the structural arrangements for the triangular shape. From doing the project we've learned so much about structural engineering, how to design buildings, but also in terms of just elementary primary stuff. So in terms of beam theory and other things just from basic principles, which we've looked at, which then combine to make the codes. This is the issue we've had, because a lot of the codes don't go beyond the scope of for a 1,000-meter tower. This is why we've had difficulties in terms of implementing them.
I certainly learned a lot about structural engineering on a personal level. We've had to investigate things which we haven't been taught. You've had to work with other team members because there's so many overlapping elements. It was a project that I think everyone can be proud of. We worked really hard on it, and I think the results speak for themselves. We did get a feasible tower that could be designed for 1,000 metres. We were limited in that we only had 5 people, and in reality a tower this size could take years to develop, but what we did in 6 months I think we can be very proud of.